form. So the H2 forms of a solid because it is a shape of an ice cube that is freezing.
So you guys are starting with an ice cube.
Yeah.
And that is, so you guys have used the terms here. You use solid and freezing. Okay, good. All right, carry on. Aubrey, you taking it away now?
Yeah. The ice cube over here is now melting, and it's kind of like a solid and a liquid. It's in the stage of almost like a liquid form, but also a solid. So it's melting down from the ice cube form from being solid, and it could turn into a liquid.
So what I really like about her explanation there so far is she used the terms solid and liquid. Can everybody see here how this is both a solid and a liquid? So somebody talk to me, or girls, you guys tell me what is changing here about our independent variable between these two.
What's changing is it starts as a cube, and then after a little bit, it transforms into melting.
All right, so the cube is our dependent variable.
Yes.
And then the melting is
Because that's the thing that we're trying to see what the change is going to be. But what is the thing that we're actually changing here?
the ice cube. No,
the heat.
So the amount of temperature, the heat. Okay, so that's important to keep in mind that the heat is our independent variable. That's the thing that we're changing. If this was an experiment, we're changing one thing to see what happens. The independent variable is the heat. All right, so tell us what's going on here on the next page.
Well, what happens there is the HP2 is a liquid now that the ice cube melted. So what I'm trying to say is it melted. It's not like fully gas yet, but it's still in that stage of liquid. But it's not like not that far apart, so it's not like this one because this one's a little bit more, but that one's less.
Okay, thank you. So what happens next here?
Now the liquid has turned in, half of it has been into particles, but most of it is still a liquid. So it's starting to rise and it's starting to like evaporate. So now it's turning into particles, almost like gas.
Okay, so again, I like that Aubrey, I like that she's used both terms because it kind of feels like, or seems like in this picture, you've got both gas and liquid, correct?
Yes.
Yeah. Just to make sure we're clear here, what's happening to the particles as you heat that water?
They're rising.
They're rising because they are what?
They're evaporating.
They're evaporating, they're starting to evaporate, which means they're starting to move a little bit more, they're starting to pull apart from each other, and so that's why we have them starting to change into gas. So what's the last picture here?
The last one is now gas, and it's evaporation. It's in that stage now, so it's not liquid or a cube anymore. It's actually gas.
The
So
whole thing evaporated.
So it evaporated.
Yes.
I like how Aubrey used the past tense because this one is now evaporated, right?
The whole evaporating, now it's just a gas.
Yeah, so would it be better then to use what's happening here? This is evaporation because it's starting to turn into a gas?
Yes.
Okay, so that's really, really important. This here is evaporated, but this maybe is evaporation. So that's maybe something important to keep in mind there. How do these girls do?
Good.
How do you guys, does anybody have something any different?
Well, I know, wait, like it won't use all the tenses. I know, but I have a different idea. What if it starts off as a gas and can it go like,
Yeah.
like what if it turns gas into like the, like, yeah, it wouldn't work.
Huh. That's a really interesting question, Michael. I really like that question. Ryan kind of had a similar thought, and Marcus was talking about this earlier too. do you have to start with the ice cube?
Nope.
Could this story start at a different
It
state?
could start as water or gas. It could start as anything.
Gas, water,
Because then that could just start freezing, and then it could get form closer and closer together.
Which I don't think it would end with the cube.
Oh.
It could,
Yeah, good.
because
Yeah.
gas
Yeah.
it can get colder and colder, and
Oh
then
yeah,
form
yeah.
into
All right, that's fantastic.
water.
So some really good thinking here. Jalen, your point is a good one as well, right? Gas can turn into solid.
No, to a liquid, and it.
Okay, so gas can turn to a liquid and then to solid. That's kind of what happens when it, like for example, when it rains, gas to liquid, and then it puddles on the ground and then it freezes. That's kind of what happens, right? All right, so this is pretty good. The key thing here we want to keep in mind though is the variable, the thing that we're changing, the one thing we're changing is the temperature. So more heat, we get gas, less heat, we get solid. And that's really important that we really understand what an independent variable is, what a dependent variable. Last question here. Who can tell me in this experiment story, what are the controlled variables? What are the controlled variables? You got an idea right here.
It's possible the weather.
All right, let's pretend here though that this is being done in a classroom.
Oh.
So what are the controlled variables? Yep. No, because the temperature is the independent variable, right? That's the thing we're changing. So what are the things we're not changing? Yes, sir.
Place.
Okay, so possibly the place,
The cup.
the actual cup itself. All right. Yes.
Maybe you don't change the water.
All right. Maybe the amount of water or the amount of material we have in here.
It's just doing its own thing.
Yeah,
You just
it's-
leave it there for like
Few
days. and
hours or
It will
days.
evaporate.
Okay. So yeah, if there's heat.
Bottles.
Yeah.
If you drink some,
Yeah.
it will evaporate.
Exactly.
Yeah, if you drink
All right.
some and then you let it.
So we're good. Controlled variables, dependent variables, independent variables. All right. Good. Good.